Do sometimes so the capacity
but if it's like at 8 a.m.
I would just
That's within 5 minutes for you. If it's like 3 hours past the deadline.
So you're saying that 250?
time to sit down. Recording will go live. Yes.
Doug is against the 250. He wants to stay with
Not too mad.
That's just that they're just this whole thing from that stands for classrooms.
So they can set up experiments on the backside.
Lecture
Before class starts, and rotate it before they start.
I'm going to borrow this at first, and then I'll give it back to you because I think I lost mine.
So we'll nail those details now.
Yeah.
And then I like oh, which I lost. I can't believe I lost to CU. Yeah, like I didn't even get so I like to have them graded. I just feel like I wasn't ready. Want to do it? Like you know, like when you're laughing, like half an hour for anything. So I was laughing. CU was like so into so then do that. Again, and I lost.
Last week,
Yeah, I graded them all last week.
wait, every single one? You did? How did you do that?
Well, because it was a right assignment. Because I'm the best TA.
Check 1, 2. Oh, that's much better. All right.
Awesome. So we'll just use this one. Thank you so much.
We're ready to roll. I just need to double check the recording started.
Okay, I'll wait
I'll
for
let
you
you
to
know
give me a
over the
thumbs up.
speakers.
Oh, okay, perfect.
They're like, pretty sure all songs got to
Yeah, wait,
change your perspective. What is it? But if they wrote a page, had proper, I think it's fine. They didn't.
Like the kids that did 2
but that's like take note. Rock star.
No, this is why I'm super happy.
You do that at all.
I know, and I wasn't like wanting to do that, but like
Oh my
it was
god.
fine. It's fine. It's fine. Now I have 2.
Thank you, Jarrell. Welcome, everyone. We're really excited to have you here. How many of you are in COEN 1500? Raise your hand. All right, you're in the right place. And how many of you are thinking of majoring in aerospace or know you're going to major in aerospace? Raise your hand. Awesome. You're also in the right place. How many of you are first-year students? Great. So you are all starting, most of you, I think I saw all first-year students, starting your first year, and you may not know that many people yet. Look around. These are who you're probably going to be studying with the next several years. Find someone you don't know and introduce yourself. I'm going to give you 30 seconds. Okay, let's come back together. So if you have questions throughout this class, there's lots of things you can do, but one of the things you can do is use the students in this class. Use your classmates as resources, so you know at least one other person now, so know to use them. How many of you have started working on your right assignment this week, making your template for your courses the next few years? Good for you who are raising your hands. Those of you who haven't, you should try to start that sooner than later. We had a bunch of great questions in office hours today from Kirsten and Joe and some others trying to figure out kind of how you figure that out, and it can take a little bit of time to get the hang of it. So I encourage you to start earlier. And if you have questions, we have office hours again tomorrow. So come then if you'd like at 1:30. There are those of you who are here in person, kudos to all of you, because this is one really great way to get to know the opportunities that CU-Boulder affords you. Those of you who are watching online, thanks for joining us. This is the Aerospace Engineering Sciences panel. We have 4 distinguished faculty members here tonight. I'm going to ask them each to introduce themselves and tell you a little bit about their research.
All right, thank you. It's a pleasure to be here. I'm Eric Frew, one of the professors in the Aerospace Department. I am the director of our Research and Engineering Center for Unmanned Vehicles. Mostly we work with drones. We do some work with ground robots and self-driving cars as well. Big focus for me personally in my research is making drones autonomous, so making them smart. And in particular, we fly them in and around thunderstorms and are trying to use them to forecast tornadoes.
Hi, I'm Penny Axelrad. It's also a pleasure to be here. I'm a professor in the department and also the department chair. This is my last year as chair, and I've been doing it for the past 4 years. My research is in 2 main areas. One is GPS, mostly applications of GPS for spacecraft and for aircraft. So I've worked on a lot of different applications of GPS, like using it for timing, using it for measuring ocean surface reflections, things like that. And then I also work on space situational awareness, which is trying to predict where satellites are going to go and trying to understand the motions that are observed by telescopes of satellites.
All right, pleasure to be here as well. My name is John Evans. I'm the kid here. If I shave, I look younger than you. I'm an assistant professor in aerospace engineering sciences. I've been here for about 4 years, or 3 years. This is my 4th year. My research is in an area known as computational fluid dynamics, and basically what I do is I use computers to model and simulate fluid flow in a variety of situations, everywhere around from airflow around aircraft wings to even blood flow around, say, the human heart valves and things like that.
Hi, I'm Jeff Thayer. How many of you attended the Meet Your Major? So I all met you then, I think, because you were here for the aerospace Meet Your Major part. Good to see you again. So I'm a professor in aerospace, emphasizing remote sensing, Earth and space. And so that discipline is a little bit different than your traditional aerospace major discipline. Interestingly, though, it introduces all of the different elements of aerospace and combines it into a research area that involves exploring space, using space vehicles, spacecraft, aircraft, as well as sensors to understand better the space environment or the aerospace environment. So it's a little bit different than the traditional aerospace major.
Okay, so this panel is really for you. This is your chance to ask questions, and I have plenty I can ask, but I'd rather that you ask them. Jarrell's going to turn on mic so that questions you ask will be heard by students at home. So who wants to start? These are your faculty. Anything if you know for sure you want to be an aerospace major, maybe you want to know about some of this research a little bit more. If you're not really sure, this is a chance to ask, how is this different from other majors, things like that. Yeah, in the back, what's your name? Joshua. Did I say it right?
Yeah.
All right. What's your question?
What's your advice on studying aerospace throughout 4 years and graduate school?
What's my advice? That's a pretty big open-ended question. I think you've already given some good advice here, which is to make some friends that are going to be in the department or in the major. In our curriculum, we have a lot of hands-on and project-based learning, so it's going to be really important to learn how to work with other people, both to get help on something that you may be struggling with yourself, but also to understand how to work in teams, how to divvy up responsibilities, how to share the load. So I think those are going to be several important skills to learn that our curriculum especially is going to rely on.
Can I answer a different question? So maybe are you asking about, is it a good idea to major in aerospace as an undergrad and grad student?
Well, I'm asking more of the way of how to go about it, of how to be successful.
Oh, what Eric said. But also actually showing up to things. So when there's an optional attendance, come. When there's an optional review session, when there's a open forum to meet faculty, or if there's a club to join where you'll meet people who are interested in aerospace, do those things. So everything that he said, though, definitely.
I'll just follow up on it. Just keep excited. That's another thing. Kind of get involved in different clubs. Like, for instance, with AIAA, there's design, build, fly competitions. Get involved with things like that. And I also want to point towards, you mentioned towards graduate school. One thing that I recommend at some point is getting to know your fellow faculty members and getting to know some of the graduate students to see what opportunities there are in terms of undergraduate research. Usually that comes a little bit later on in the undergraduate curriculum, but it's always a good idea of kind of being aware of what's out there and what sounds exciting to you.
Clarify if anyone's confused. You guys are all in undergraduate right now, so you're in your first 4 or 5 years of school, and then graduate school is something you can pursue after undergraduate if you choose to. It's more school, it's much more specialized. And we have those opportunities here at CU-Boulder because it's a university. I want to follow on Joshua's question. What sorts of things do students do when they graduate from your department?
So in our department, most students go into industry. So I would say probably 75% of our students go to work in the aerospace industry or work for NASA or the Department of Defense in doing GPS. Not that many do GPS. Doing some kind of aerospace engineering. So working as system engineers, design engineers, test engineers, that kind of thing. The rest of the students, probably 20-25%, go to graduate school to pursue advanced degrees, and then some of them go on to become professors or go on to be research engineers or research scientists at national labs. That's a common pathway for someone who does advanced work. But most people go work in the aerospace industry. Colorado is actually the third largest private aerospace economy in the country, so California is first. Usually Florida or Texas is second, and we're number 3. And we actually have the largest per capita aerospace employment in the country. So a lot of our students do stay in-state. Many also then go to California or Boston area is another popular place where people go.
I'll just add that aerospace engineering is more than just working on aircraft and spacecraft. A lot of the things that you learn can be applied in other areas. So when we say industry, that might be working for a car manufacturer. Trimble Navigation is located nearby in Westminster. They do surveying equipment, so surveying construction sites. It's based on GPS, which is a fundamental aerospace technology. So industry, again, doesn't mean the big companies, spacecraft, aircraft. There's a lot of different places that the skills are used.
Other questions? Yeah, what's your name?
Matt.
Matt.
How early would you say we should start looking for an internship?
Yeah, you're welcome to pursue internships now. I mean, freshman year, you can start looking.
Is it feasible to get one this early, though? Like, does that happen?
Yeah, they do. I think the thing is, what I've seen is that students tend to, you're not quite sure what area you're interested in. And so you tend to blanket. You'll do a blanket, kind of cover a lot of different areas, a lot of possibilities for internships. And that just increases your probability of selection. Of course, there are juniors and sophomores possibly competing for those same spots. And but I would just say that I've talked to some students about it as well, and they said they did a lot of blanketing. They really did just cover it. And the other things that you really don't know what you want to do. So even getting internships in something that may not be, right in your area that you think you want to be for aerospace, it's just that experience that you're really taken away that'll be beneficial in the end. So don't get too hung up on, I got to work in something in terms of the space industry because that's what I want to do, without exploring other opportunities that might come across.
There's a career fair in, I want to say early October. There's the technical career fair on campus. You want to get your resume together early for that, give career services a chance to review it. If you know how to program or you have practical skill, if you know how to program, you can probably get an internship. And if you have other practical skills, like you've worked on electronics or there's something you can take away from your freshman projects course, those are the kinds of things that can help you get an internship even as a freshman. And go to that career fair. The other thing, too, is if you're a U.S. student, some of the companies that want to hire people to work on defense stuff like to get students in as freshmen and then have you come back subsequent summers. So there are sometimes specific calls that are looking for high school or first-year student internships. You have information on that, too?
I want to ask a question. How many of you are going to make your resume this semester? All of your hands should be up because it's an assignment. How many of you are going to the career fair? All of your hands should be up because it's an assignment. Everyone has to go. And just to your point, Matt, because you just got to see what's out there. And like Jeff said, you want to just kind of understand the kind of opportunities that are there. And you're not going to get one if you don't pursue them, if you don't look into it.
Another opportunity that you could consider is internal to our department, just as we all have research labs and we all have students working in those research labs. And there's a thing called the Discovery Learning Apprenticeship that we have in the College of Engineering. And those are projects that faculty put forward, and you can apply to those projects and choose which one you think looks most interesting. And then and that's another way. And sometimes maybe as a freshman, if you're not getting that exposure outside, you can get the skills such as programming or something along those lines that'll make you more marketable in the future. So.
Other questions? Yeah. Remind me your name.
Yang.
Yang.
So this question is more on nationality issues because I am not a U.S. citizen. So what are the chances of getting an aerospace-related job as a foreign national in or outside of the U.S.? Sketchy.
So you're asking getting a job outside the U.S.?
Or outside the U.S. that is not my home country.
Yeah, that's really hard for me to answer. So internal to the U.S., there are some companies that don't require U.S. citizenship. So I think probably on the drone side, anything science related, there's much less restriction on citizenship. But a lot of the big companies that do government work are only taking U.S. people. And then in terms of outside stuff, there are internships in other countries that are open, broadly. But you'll need to look for those announcements early, so you can look for summer internships ahead of time and apply early.
Thank you.
But again, remember, aerospace is more than just spacecraft and fighter aircraft, so there are lots of opportunities. If we'd had this panel 5 years ago, I would have not listed Google, Facebook, Microsoft as aerospace companies, but they're all building aircraft. So there are lots of companies that don't do defense work, which is where the restrictions tend to come in. So I still think you're going to have lots of opportunity. They just might not be what you think of as the traditional aerospace company. Yeah, so I do drones. There's lots of small startup companies around the world that are doing things with drones and other types of unmanned systems. Small businesses, you could create your own and go where there are interesting places to fly things, for example. So again, the traditional big aerospace companies often have issues about citizenship, but there's so many other things happening in aerospace.
Yeah, what's your name? Lauren.
You mentioned that we should be applying early. If we're looking for an internship over the summer, when should we be applying? October. Okay. I know at that career fair.
Yeah, there'll be companies. Yeah.
You want to have most of your internship applications in before the career fairs, right? Because then companies and employees that are looking at you can say, hey, I've already applied to you, and then you'll already be in their system. Right? If you're already in their system and you show up at the career fair, then you get bumped to their next tier that says, okay, this person's also interested at the career fair level. Let's look at their application. Let's see where they're a good fit. So start now. Good.
But don't panic. If you haven't already done it, that's okay. And the companies do come back a few times. So there'll be this October opportunity. There'll be another one like February, and there's another one later. But he's absolutely right. The sooner the better, but don't panic.
Yeah, in the back. What's your name?
Nick.
Nick.
What does an engineering internship generally entail? What kind of work would you be doing?
All sorts. I don't know what to say.
A lot of people do test. That's a really common thing. I think mostly sophomores and above. We'll go into some kind of system test, evaluating performance. Yeah.
Well, I was just going to say, though, programming is a central element. So you could be doing coding. Yeah, it's quite varied. I'm having a hard time actually thinking about what. I think one of the things you might want to think about is, as you look at these internships, is I think you're going to take in a way, at this stage, where you might be like, I'm just going to take whatever I can get. I'm going to take it and I'm going to work it. I think the thing to do though is to try to understand whatever they're having you do. Try to understand why and see if you can get some insight from the internship, not just the skill sets. But yeah, it's tough to say. I can't say that there's requirement documents.
I was going to say, most of the folks that I've known that have gone on to do internships, and this is not just true in aerospace, but it's also true in many other engineering disciplines, often will be working with software of various sorts. So that includes programming, for instance, knowing MATLAB, being comfortable with that. I have a student who's a senior now that basically was doing MATLAB programming all summer for Lockheed Martin down and south of here, as well as being familiar with computer-aided design packages, other analysis packages. That's useful from getting a job perspective. They're looking for people that know that ahead of time, and a lot of people will be doing that early on, as well as sometimes it's just fun to play with those packages.
I talked to one student who got an internship. He was kind of a tinkerer in high school, like he did robotic stuff, and so he got a summer internship where they had a test fixture that didn't work very well because it took too long to put stuff on and take it off. So his job was to design a new test fixture that would be more efficient for the testing. So he actually did mechanical design and machined it and put the thing together. So it's pretty varied.
And Nick, we're going to have a couple more panels, one of which is a professional panel, professionals who actually hire interns, so you can ask the same question then. We'll also have a student panel where you could ask students what their internships have been like. So you can look forward to those. Yeah, what's your name?
Jared.
Jared. Yeah, go ahead, Jared.
How many students do you usually hire in your research labs? And is it mostly upperclassmen, or do you have a pretty good amount of freshmen too?
Again, it really varies faculty member to faculty member.
Right.
I do a lot of flying. We go outside and do a lot of work. So I'm currently have, I'd say, 9 undergraduate students working in our group, just different sorts. And most of those right now are going into their senior year. I taught them as juniors. But I've had a high school student working for me one summer. I've had sophomores. I had one student that I currently have who started basically with me as a freshman. So it really depends. But I have 9, but I think that's a large number.
Sure. So I'm typically on the other side. I typically hire senior level undergraduate students just due to the nature of my own work. I'm a bit of an imposter. My degree is actually in applied math. My dad was a pilot, so I like to think of myself as being more aerospace-y. But there has been exceptions in the past in both my own research group and others that have been more involved in computational research, and that really has to do with background. For instance, if you did a lot of programming in high school, for instance, there would be a lot of people that would be interested in picking you up early on just to kind of get you under their supervision, kind of teach you the ways of their own research group. So then, by year 3, say the junior year, you're really contributing.
Maybe you can also comment on how you might go about finding a research position.
I think one of the things. So I have 3 undergrads and then 10 undergrads that are all 10 seniors that are associated with the senior project, and then 3 undergrads that go from sophomore, junior level. I think one of the things that I see a lot is that I get to know the sophomore students because I teach the fall sophomore class, and so a lot of us get to know you that way, and you get to know us that way, and then usually we get a rapport going, and we have you guys come work in our lab. It is a little bit harder at the freshmen just to meet you guys and to know what your interests are, and I can't say that my website is particularly clear as to what I do enough to get you to want to come work in my lab or whatever. But those opportunities, there are opportunities in different ways that we can be creative to get you involved. I've had students who volunteered their time. They're like, I don't really want to be paid or anything like that. I just want to be in an environment where I can learn from. So I have 5 other PhD students, so my PhD students kind of work with the undergrads, and so they get a chance to, see how the progression is and just see those kinds of things. So that's another way too.
So also, I'll just add, when it comes to sort of internal opportunities, there are a couple other places on campus that do a lot of aerospace work. One is LASP, the Laboratory for Atmospheric and Space Physics. They hire a lot of students. They run mission control centers that are talking to spacecraft, and they have students that are doing that work. Also, Space Grant is located on the second floor of the DLC building. They hire a lot of students. So you don't necessarily need to come to the faculty to find an aerospace engineering opportunity internal to the college.
Yeah, in the blue shirt. Ready? Yeah, you. I think it's blue. Yeah.
Brady.
Okay.
I'm hearing programming a lot, but is there any other classes or skills that you could maybe minor in to complement the aerospace?
If you want a fun one, astrophysics. There's a lot of fun classes associated with that.
I think CS minor or electrical engineering courses are pretty helpful. Excuse me. We're actually in the process of starting, it was in the newspaper, but we're starting a new BS-MS program joint between aerospace and electrical engineering, specifically in RF engineering, that's electromagnetics. And so if that's something you're interested in, starting to take some courses in electrical could set you up on a good pathway there. But pick something you really like don't just do it to check a box, right? Pick something that you really want to take. That's what I would suggest.
Yeah, next Brady.
What about the news? I've been hearing a lot about that, and I kind of want to know how it ties in with aerospace as a major.
So aerospace majors can do a minor in space. The minor is not too complicated, right? There's the one required course, which is going to be Pathway to Space. If you're an aerospace major, you're probably taking Gateway to Space instead of GN 1400. You might be, you don't have to, but you could take ASEN 1400. And then try to pick for your minor. I would suggest picking things that are not from our department, just to get a broader. The reason to do the minor is to sort of explore different things. So take the astrophysics and take the space policy and space law and stuff like that, astrobiology. But yeah, you definitely are eligible to do a space minor even if you're majoring in aerospace.
Yes. What's your name?
Jacob.
Jacob.
So back to internships, what would you suggest for out-of-state students? Looking at an internship back at their home state or looking at one out here?
Apply to both. Yeah. Of course, it'll depend on your individual situation, financial, otherwise. I think if you just sit there and apply to as many positions as possible, especially earlier on, you'll have more opportunities that will arise. So I think of it that way.
The less picky you are about where your location is, the more likely you are to get an internship. So there's companies like in Cedar Rapids that you're probably more likely to get an internship than Google and Mountain View. And other places, like if you're willing to go anywhere in the country, there's a lot of companies in Florida, Texas, California. If you say, I'm only going to Boulder, that really limits your pool. But if you apply everywhere, you probably find something.
I have one question I want to make sure we get a chance to answer, which is what general advice do you have for first-year engineering students to help them be successful?
Well, let me address. Yeah, I can address. So to be successful, then you're going to be transitioning from freshman to sophomore, and then sophomore to junior, senior. And since I'm I teach the class that you first. I think I talked about this when I talked to you guys at Meet Your Major, but the sophomore year is your first immersion into the major. Your prereqs are covered with what you're taking through your freshman year. And I always hear from the students, it's like a big shock, that transition. And I think part of that is, I know a lot of it is just their time management, just the way they try to be successful. You have to try to be clear about what's important to you. The peer pressure and the other activities that are happening. If those overwhelm you, then you may have trouble with your time management of handling the coursework and the things that are coming ahead. So I think in freshman year, if you can do a good job of being organized with your time, and I think that'll help you along the way.
Sorry, I don't mean to talk so much, but the one thing that I would suggest, you're all great students in high school, right? And so maybe you've never before faced this idea of you don't know what the teacher's talking about, you don't know how to do the homework on your own. So the number one thing that will help you be efficient is to not be afraid to expose what you don't know. So answering something wrong, saying you don't really get something, don't just nod and smile and say, yeah, I get it, when you really don't get it, because you can sort of coast on that for a little while, but when that, we really do, prerequisites are really important. So if there's something you don't get in your calculus or physics class, don't be embarrassed to go talk to the professor or talk to the TA or talk to your friends and say, I don't understand this, I keep doing it and I'm getting a different answer than is in the back of the book. Where am I going wrong? And people can help you a lot more efficiently if they actually know what it is that you don't know. So I know students don't like to tell when they're wrong, right? You want to use clickers and you want to hide and pretend like you get it. But if you can get past that and really show what you don't know, you'll learn a ton, and it will be a good life skill. It'll really help you be successful.
I was going to actually expand on that a little bit. Go to office hours. Folks are there to help you. Don't be embarrassed to go. And actually, within office hours and outside of office hours, discuss methodology of how to approach problems with your classmates and things like that. The best way to learn something is to try to teach it. So going through every single step, and that will make sure that you really truly have a command of the material before you go into your sophomore classes, which will be really where it ramps up.
And just a slightly different perspective is also remember to build a community here. It doesn't have to be around your major. If you're interested in the sport, if you're interested in performing or some other opportunity, make sure you're taking the time now this year when things are probably a little bit easier on the school front than they're going to become when you get into the majors. So build that community, whatever that activity is, and you'll find that once you're established there, it'll be easier to keep that going when you enter into the sophomore, junior year. It's a lot harder to establish yourself on a new sports team or something else. So, and again, it doesn't have to be your major. So just find whatever that passion is for you outside the classroom as well as inside.
Please join me in thanking our aerospace engineering science. Tonight, I really appreciate you showing up and being attentive and asking questions and being great listeners. I so appreciate those of you who show up and ask questions, but I have a little something for a few of you. Chloe and Alexis, you will get first. You come on up. And Joshua, you ask the first question. And Lauren and Brady, come on up. I have a little something for you. The rest of you have a great night. And I hope to see you the next panel.